Hello everyone, welcome back to my channel. Today let's go over another medium question that I just solved on my own. So this was the contest question that I think I ran out of time, but I actually just tried this on my own and was able to solve it without any assistance. So I'm really happy about this. Let me show you how I did it. So basically I just used the brute force approach. This one's not too bad. You have a grid and you want to find the smallest absolute difference between any two values in each submatrix. So that's exactly what it sounds like. So let's just iterate over the grid to get each cell. Why does my return key keep not working? So let's print I and J. Cool. So now, how do we know that we have a submatrix of K both horizontally and diagonally from the current cell? Well, we can say if I plus K minus 1 is less than length of grid, and I plus K minus 1 is, this is going to be for the columns, grid 0, then we can print I and J. So we know that's a valid cell. Okay, cool. So that confirms it right there. And cool. So now this lines up with how many elements are inside of our result, which is just going to be a matrix. Let's call this current row. Cool. So now we can just say for row in range I to I plus k, for column in range j to j plus k. So we're just going to go over, like, for example, if we have this submatrix, it's not a good example, but let's say 2, 2. So that's just going to be the whole thing itself, right? Just draw a square and use K as the buffer. So now we can just say we have a sorted set because we only care about the distinct values. So then you can say now dot add grid of row column, and at the end we can just print now. So it's only going to be true if there is a good submatrix. Okay, so now we just have to take, so let's call this cell is float of infinity. We just have to say for each value what's the smallest to the left and to the right, if there is. If there's not, then it's just, you know, same old deal. Just go here, compare the left and right, iterate left and right all the way to the end. So for I in range 1 length of now, let's call this U because we don't want to mess this up right here. So we're going to obviously take the minimum because the minimum absolute difference between now of U and now U minus 1. So the previous element, and if U plus 1 is less than length of now, then we can also take the element to the right because sometimes there's not a right element, for example, when we're here. So now it goes to minimum of current absolute now of U minus now of U plus 1. And if current, or if cell is equal to infinity, then let's call this cur row dot append 0 because there's nothing there. Obviously the same element can't be used twice. That's why we have the hash set in the beginning. Otherwise, append cell. Okay, so now at the end of this, we can just print cur. Cool. So if current exists, if it's not empty, then we just append that to the result, right? So if current is not empty, then result.append cur. And at the end, we can just return the result, right? Very straightforward. Submit this. And there you go. Passes all test cases. Again, it's not very efficient in terms of runtime or memory, but I did come up with this solution on my own, so I'm pretty happy about that. And that's it for this video. Thank you for watching and stay tuned for more as always.